Thank you, Tim, and good morning, everybody. I think August had made it slightly easy for me. So what he has shared in a lot of the vision and strategy is what I actually labeled it, vision to reality, and one of the things that we have done in Japan is maybe a little bit of an unorthodox thinking to move away from a traditional deployment for telecommunication infrastructure to a truly cloudified experience in which you look at the network as a whole and an end-to-end virtualization story and end-to-end cloudification, especially in the areas that I believe that this industry needs quite a bit of innovation, quite a bit of disruption, which is the radio access. So today, my objective with you is to share a little bit more than just a technicality, more towards really the personal philosophy and the insights of what we have went through to get to where we are today. And the first phase was, I call it creating the vision together with giants, because this actually might sound slightly illogical about what we have done to convince very large companies about the concepts of open networks and the advantages that it could bring to them. And this was not trivial. So the idea that we started with is completely a white paper in June 2018. I knew what we should build doesn't necessarily exist yet in the industry. I knew that challenges are enormous, but I knew also the value of partnership and collaboration, and the value if you put the right partners that share the beliefs and the philosophies with you together, what could happen. And my first discussion actually happened with Nokia. And maybe some of you would be surprised about this, but I spent enormous time trying to convince Nokia, its board, its CEO, about the concept of open, disaggregated radio access. I told Nokia that I think I have a path for you, that if you look at Rakuten as an entire account, your P&L would be extremely profitable. But in order to do that, I look forward for you to think about an opportunity in which you sell me only the remote radio head. I had a dream in which we wanted to have full control around the software. So the concepts of virtualization of radio became very important. And I'll explain to you why we believed the radio virtualization and open RAN is important. It's not just necessarily, by the way, about the idea of open, the CPRI into eCPRI and the various interfaces, or decoupling of the CU to DU. It is what is the impact in network operations, and the efficiency realized is what is so attractive. And I'm going to give you some really big examples of what we have done to realize the benefit into our network architecture. So 4 big success factors was about virtualization and decoupling of RAN architecture. The second thing, this is actually learning that I cannot personally take credit from this. I would give Facebook quite a bit of a credit about this. I had a visit inside one of their data centers, and I was really amazed. I looked at the entire data center and everything looked the same. I was just absolutely shocked. So I asked the engineering team there, I said, how do you guys run your software infrastructure? How do you run your code? And that's where, the learnings to me came about. They said, Tareq, we only have 6 hardware types. We have a hardware type for storage, hardware type for AI workloads, hardware type for this type of application. And if you really look at telecom in general, and you ask how many hardware types do exist today, and still, despite how many discussions we had around cloudifications, virtualization, we still have a number of enormous variation of hardware types, some proprietary, some COTS. But the dream to complete cloudification was completely, I call it a mirage. It's still not there. So this was another big factor. We said the entire telecom network of Rakuten also needs to run on 6 hardware types. And these 6 hardware types is all the same, except there's slight variation of memory, storage, to that extent. And the other factor that I wanted to do is I will never allow a vendor to come to me to tell me what hardware type their workload needs. We discovered in the early days that the cost of also CPUs is not necessarily a cheap components. So we looked at the CPU architecture and we determined the right performance to core count that met our objective. We forced our vendors to think differently. I said, if your workload cannot guarantee the throughput, your software code base need to be better optimized. So the hardware standardization was a critical thing for our automation, supply chain, predictable operation, and so on. And then, of course, the right mix of edge and central data center. So in our current architecture from day zero, we had something we call far edge. Far edge is about 30 kilometers away from a site. It hosts our ultra low latency applications. vRAN turned out to be one such application that is contained in the far edge. We have regional data centers in which we hosted the UPF work loads of packet core, as well as CDN and other media content and application that would benefit from low latency deployment. And then, of course, the central data centers, which is mostly hosting our control planes, such as HSS, OCS, PCRF, IMS core, and so on. And the consolidation of these vendors, we had to act completely as the system integrator, bringing people together. And during this journey, it was not trivial whatsoever. Whatever you hear and understand about virtualization, the more that we got into it, the more we realized that when you look at it holistically, it is just still not there. We had to address a significant amount of work on how the VMs themselves interwork among each other, how the VMs could be orchestrated. And to be very honest with you, I mean, the biggest surprise to me is no matter how many standards that we have pushed through, the vendor compliance to such standards is also different vendor to vendor. Their capability to deliver on what we all want, which is an elastic VM, one that is able to elastically grow, heal itself, and address the key requirement of what I would consider basic cloud architecture was not necessarily there. But we've been through it. When we got through a lot of challenges and a lot of very interesting early days on. And for sure, the most complex one of them all was the VNF of radio. And I'll explain to you briefly why that was challenging. So the approach that we have taken is we said, look, the Open RAN is so important. And when we talk about Open RAN, we dreamt about an idea in which there should be no electronics whatsoever at the eNode B. And the logic behind that was, what happens if you don't have field technicians? I mean, just as an idea. What happens if you don't have back office engineers? What happens if LTE and future 5G becomes nothing but managed Wi-Fi service? It's as simple as plug and play. And I think all of that was a thesis that we saw, and we wanted to really push through it. And with our launch in our network, we completely saw the benefit of virtualization, especially in the radio. And the moment that we moved the radio as a VM sitting on a COTS appliance, 30 kilometers away from an eNode B, I would tell you, I immediately said, we are just absolutely scratching the surface of what is possible in terms of workload optimization, radio optimization, and all of this industry standard things that we got used to for decades. I think we see a path in which we could completely remove the old way of working, the old way of engineering, the old way of operating. So I'll show you a picture, and maybe this actually will resonate with what you saw in the previous slides as well. So this was actually the first eNode B that we have installed next to our headquarter office. That building next to this is the headquarter. Now, what happens if all what you have on a macro base station is this? The approach that we've taken is very simple one. We said, look, we really don't want jumpers, connectors, but at the same time, we could not afford to go through a level of R&D to integrate the remote radio head directly into the antenna. So we worked with a Korean company and we changed the interfaces of how a remote radio head integrates with an antenna without changing the remote radio head. Creation of a simple, in this case, plug-in adapter that plugs to a back of this antenna. We took a process that took days, and now I would say if you see the architecture of this adapter, it has no weather taping, it has no cables, jumpers. So of course, RF propagation will be better. This is a 44R system. You bring fiber to this. This remote radio head is Nokia remote radio head. We worked with Nokia and asked him, can you please open your interface? At the time, by the way, the industry standards, when you think about Open RAN, it was not to a point where we could just say, hey, let's just jump on it and make a complete O-RAN architecture to what we need. So what we did is we took the concept of O-RAN, and I took the CPRI, and I have a small little box that took the CPRI and converted to eCPRI. So everything becomes IP, and it terminates on the far edge data center. So the overall network now become a Lego box. Everything looks the same. Everything is identical. It is almost the analogy of having a low-cost airline carrier. It does not mean low quality. If the parts are the same, that means technicians becomes the same, replacements becomes the same. We felt that the cost structure could be remarkably cheaper with such an architecture. And if that's all what exists at a site, maybe we have an opportunity to even change the concept of field maintenance, preventative maintenance, all these things. We think that we are on the verge of completely removing such organizational structure on the network side. The other thing that I learned quickly is it is really, really easy to do a proof of concept and a POC on Open RAN. I would tell you, probably not because we think we're better, just because I think we went through a massive challenge to understand that scaling Open RAN was an utter challenge. Oh my goodness, this was not easy. I mean, I've learned a lot of things, frankly speaking, in my entire life, I've never really ventured into. I've learned a lot more about microprocessor code architecture of Intel, understanding the key features that unfortunately today, the current microprocessor architecture is okay, but it's not great to what we want Intel, AMD, and others to focus on in the future. When we think about predictable workload and ultra low latency that radio access require, because your TTI requirement is so sensitive to this latency, you cannot avoid having any jitter that happen at this server. You cannot avoid the concept of noisy neighbors. You cannot avoid having the CPU pinned to this specific workload. So we've done certain things. If you ask me, I would say it's good. It's not great yet. It could be better. And I'm sure, with help and support from ORAN, ONF, and other industry to help us push through, acceleration and innovation of this, it will get better. But here's what we've accomplished. To put exactly 16 mobile base station on a commodity server with 2 FPGAs inserted into it, that's not too bad, in my opinion. It's not yet still ideal to where everybody wants it, but 2 PCI additions on a server, we thought this is not a complicated thing. By the way, this is a completely 2U4N architecture. We created also from the ground up that is, currently hosting all this far edge workloads. But the same server, coincidentally enough, I use also for 5G. So I'm not necessarily buying different servers. I mean, all of this is a pluggable architecture. I love the idea of commoditization. It really, really makes total sense. Utterly, utterly beautiful. Once we get to hopefully in the near future, better microprocessor architecture, embedded acceleration into these CPUs, you'll discover a lot of things. But the scale is what was fascinating. I mean, I have never felt more stress in my life. I remembered actually February 2019. Our chairman and CEO came wanting to see now a live demo, and he brought even his video crew. He wanted to film this moment, and everything was crashing. Everything. I'm like, oh my God, what is going on? The moment that we start putting traffic, and the moment that we went beyond 5 UE attached, this is where it got becoming interesting. The scale did not work really well in the software. And then we improved together with Altio Star, the software code base, continue to believe that software will prevail. And in fact, that's what we did. And now, we have a 700 RRC connected user, per sector, times 3, times 16, supported in this concept. I would say it's not bad at all. So I think very, very good improvement that what we have done on scale. And one additional thing I will tell you, I think for Igal maybe and the team will tell you about this. We upgraded the radio software 3 times a day. You tell me one radio vendor in the world that have the capability to upgrade at scale with in service, with no service interruption, if you don't move to a software-based architecture. So, when you think about it, this is what I wanted to see, a more service agility, the ability to do inline service upgrade, and the ability to push not every 6 months software update because I'm afraid to upgrade my network. We should think about this network as a completely demand elastic network and able to scale. We invested. Look, if you look at telecom in general, I think it's an industry, unfortunately, that does not reward enough startups. There are many brilliant startups that exist across the world, and we wanted to reward the key ones that believe in this disruption. At the time, we believed that LTO Star had the best software potential. By the way, I never gave him an RFP. That's another thing. I never gave a compliance criteria to LTO Star. I believed from day zero they're going to have massive gaps, and my job is to build an ecosystem around them to address these gaps. And that's what we brought. We brought Intel, we brought Qualcomm, and we brought many others to help facilitate the improvement of the software stack for LTO Star and the hardware. So we built our first generation with Nokia. We even partnered with KMW on integrated remote radio head. We built a very, very ultra low cost solution for 28 gigahertz together with Qualcomm and Airspan, and build a massive MIMO 32T, 32R that is all powered by the same software architecture for both indoor, outdoor deployment. When you look at all of the products that we have done, when you think about all of these from the ground up, what is so unique about all of this approach? And maybe my approach is slightly different. When I think about vendor disaggregation, I actually was thinking, it'd be really cool if my hardware layer is disaggregated, meaning I could buy the hardware from anybody. I could buy the hardware from Nokia, KMW, Airspan, Sercom, any small company, big company, it doesn't matter. And I believe maybe in the future, the likes of Nokia and Ericsson will open their mind, Samsung, and say, look, if people want to buy my hardware, buy it. And you sell a la carte. People want to buy hardware, software, you buy it. But for me, and what worked really well for me, is the unification of software layer. So I have one software that runs all this portfolio. And I have the same option split across all of these products that is enable me to have the operational efficiency I need, the manageability that I require. There is no need about managing multiple EMS. And in fact, I will tell you, for 5G, we have eliminated absolutely the entire element management system architecture and moved to completely what I call a web scale architecture for observability framework implemented on radio, which I think is also a world first in this approach. We also said, if the VCU has the ability to manage Wi-Fi, LTE, can we integrate now Wi-Fi controller to be also part of the manageability of both LTE and Wi-Fi? And we've done a lot of integration in our own cloud Wi-Fi architecture to have both LTE and Wi-Fi managed by the same cloud infrastructure. I think this is one area I am personally really, really interested about what ONF is doing on the REC controller. But one thing I'm going to tell you, I have done not necessarily the full apparatus of what the REC controller intends to do, but I want to tell you small glimpses of the possibility why I think the REC controller and the team in ONF is going to do a great job in this, and I'd love to support them in this initiative. Imagine going to a very large traditional vendor and say, Mr. E or Mr. N or Mr. H or Z, can I please integrate a small little API agent in your base station stack? I guarantee you, most of them would say, absolutely not, that's not gonna happen. What we have done together with LTO Star, and you could see, I believe that there is many smaller interesting companies that have already built beautiful manageability platforms, better maybe than the OEM. So I wanted to integrate third-party SON as an API with the current radio access infrastructure that we have. Today, the SON is provided by a small entity. It's not provided by LTO Star, but it does a lot of very elegant things. It does RET management, interference management, optimization mobility, outage detection. And all of this is done as a near real-time API, and near real-time changes happens between the VCU and this integration layer. And I plan to take this architecture and work with ONF, hopefully to move into a fully compliant RIC implementation for this platform. But we are ready today to embrace this world in which third party could come in, integrate with this API management layer to achieve better results on the efficiency. So I think the other thing, I mean, how do you scale now for performance? We have in the first phase fully virtualized the VNF. We have every single thing. I don't have a single bare metal whatsoever in the network. One horizontal cloud, 182 unique VNFs today deployed in the network, and a massive underlying dark fiber network that was built in 2 years with 8 tera connectivity, supporting both 4G and 5G traffic. And this is where I wish I had more time to speak to you about why O-RAN is important. No, we don't speak enough about this. So the industry as a whole talks about the importance of disaggregation, clearly understood that you could reduce price, but why O-RAN and why virtualization and why cloud is important? Well, there's many reasons, but the first thing I noticed is you will be able to completely remove the philosophy of operation and thinking from the old way. Today, an eNode B in Rakuten network does not have data fill, does not have data translation, does not have BSS engineers, doesn't have OSS engineers, doesn't have any of this organization. The second a fiber is plugged into what is called this RU, this radio interface unit that sits next to the remote radio head, everything else now is abstracted because of the elegance of how VMs comes in. We're able to instantiate a VM in less than 8 minutes. In my previous job, this took days, by the way. It took days, and then sometimes you have to send field technicians to connect a laptop to the BBU to download the configurations and worry about cell design data. In my world, this just doesn't exist. Complete embedded automation that takes days into minutes is becoming a reality. Then we looked at the OSS, massive transformation in OSS. We completely divorced the idea that every product in OSS have to be monolithic silo, and ended up partnering with a very good company that build a very innovative OSS platform to help us continue to build the automation that we require for this network. So reality check, is this really real? Does this network work? Does it work in urban area? Absolutely. Anybody that wants to see Open RAN in the heart of the densest network on the planet in Tokyo, please come here and see the performance of O-RAN at scale. This is no longer a POC with over 1 million customers signed on. Every single site looks alike and looks identical, connected and fiberized, with only the baseband deployed as a VM hosted on the edge data center. I really think that this is absolutely real in terms of its capability, capacity, performance, and what I see today. I keep mentioning this again and again. It's just scratching the surface. In terms of how does this current architecture scales, I am beyond satisfied about the key metrics around drop calls, accessibility, retainability, but still so much work that could be done. And in terms of software world, I think this is endless on what is the possibility and what could be achieved. So we've comfortably achieved a very, very good performance, I think, on this area. So in summary, I think vRAN is a key enabler, whether you call it vRAN, Open RAN. I really believe they all have the same intention. Of course, we need to follow the industry standards, but I think we also need to focus on what is the end destination and objective. Full automation. Full automation is the holy grail of what people want. A network like maybe Tesla that is dreaming to achieve level 4 autonomous driving, a network that has level 4 autonomous capability. I really believe that we are multiple years away in Rakuten Mobile to achieve that with this current platform. And then last but not least, I think this is something that I am thinking about a lot, is how do we prepare and share Rakuten Mobile experience with the rest of the world? I wholeheartedly believe in open source, wholeheartedly. I don't believe at all anything should be locked and should be proprietary. We have created many great innovations and would love to find a path to collaborate with great industry leaders such as AT&T, great forums such as ONF, ORAN, to how we take what we call this Rakuten communication platform and look at what really worked well in it and how we work together to make it better. Because I think we do, it is not just about the story of Rakuten, but it's a story in which we have validated the industry vision. We think it's implemented in Japan, not to the fullest of what it could be, but together we could be much, much more aligned to the end goal. So we learned a lot in 3 years. We learned the practicality of how to build a complete marketplace for telco and IT workload, complete open DNA, designed from day zero for cloud native. It's application agnostics. I talked to the biggest OEMs in the world to say, hey, would you be interested to onboard your application on the marketplace that we're building, optimize for real time, and absolutely build for telco industry? Because you know very well, an IT cloud infrastructure and a cloud telco infrastructure, in my opinion, has a significant differences in capability between the two that we have enriched and enabled in this platform. So again, big believers in open source. And with that, I thank you very much for listening to my speech. Sorry, it took maybe slightly longer than I wanted to, but I hand it over to Igal.